Let's wait for 2 more minutes. Then we can start the session. At first, we'll be discussing few updates about the program. Let's start with that. 2 more minutes, please. So, meanwhile, I'm starting the YouTube live as well. Please inform all your friends to join in the session. Just 1 more minute. I think we can start the session. Good evening, everyone. I hope you're all doing good and welcome back to our technical sessions. So as usual, before starting the session, we have a few updates for you. All right. So you might have seen the update already in the Telegram group. We have sent you a video reference, like how to update the link, how to paste the link in your in the place of uploading your achievements and credentials. So in that place, we have given you a small update. Okay, in yesterday's session also, we have discussed the same thing. How to copy the link, where to copy the link and how to paste it and everything. The detailed video is also being shared in the Telegram group. Please do refer that. And also along with that, I'm going to tell you the long awaited one, your offer letters can now be downloaded from the LMS platform. Okay. Your offer letters are live now. You can download them from your dashboard or LMS, we call it. Okay. Let me show you a live demo of that as well. Let me share my screen. Right. So usually how you go to LMS. So you have the link, right? ainsi.edunetworld.com. So this is the link. Right, so this is how it appears. If you are not logged in with your registered email ID, you won't be able to, you might have to do the login all again. But usually, for most of you, it must be logged in already. So this is how it appears. And now you have access to basic and intermediate courses as well. So I can even show you that. Basic courses are there, intermediate courses are there, because like many of you have raised this as a concern, ma'am. Already I'm done with advanced courses, completed all those modules. Now I would want the access to basic and intermediate. The access is granted. You now have access to complete the courses from basic and advanced. So the main thing here is while you come to advanced, okay, for whatever courses that you have completed, you know where to paste the link now. For example, I'm going to this course. So these many courses already I have completed. So if you go here, this will give you the option to paste the link, right? Paste the link. We have sent you a detailed video on the same. You can click on view course, right? Already all these modules or units are completed. So I can directly click on complete module. See, this is my achievement. Usually I take a screenshot of this and upload it in this place, correct? In this place, I usually take a screenshot of this and upload this page. But now we would want you to copy this link. Okay, there is this link option. You can copy this. Once you click on that, it will give you a pop-up like this, achievement and the course name. You can see the arrow also. You can double click on this arrow so that the URL is copied. Now, to check this link, you can open another tab. You can paste this link and click on enter. You'll be able to see a page with your name, the date of completion of that particular course will be there. Okay, so this is how it appears. Correct. So after that, you can go back to this page and click on this option and you can paste your link here. Right? You can just paste this link here and submit it. So this is what you all need to do for all those completed courses. Clear, all of you? This will add more credibility to your completions or achievements. Okay. So this is one update. Second update is you can now see this offer letter option on your dashboard. Again, I would like to repeat. So you will be able to see this offer letter option only when your ID is registered with AICTE. So already we have sent a student ID PDF yesterday in your Telegram group. So if your student ID is there in the sheet, which means you are registered with AICTE and you're eligible to pursue this internship. Okay, so you must have gone through the PDF. If not, go to the pinned messages in the Telegram group. You will be able to see the PDF with your student ID. Okay, number one. Number two, if you are there, which means you are selected for this internship and you're attending this and you're also eligible for this offer letter. Okay, so first thing is you need to check whether you're logged in with your AICT registered ID or not. So once you are logged in, you will be able to see this option offer letter on your left hand side. On your left side, you can see this offer letter just below raise a ticket. Okay, offer letter. You can click here. So there are few important, lines given here or important points given here. You just have to go through this. Before downloading your offer letter, please make sure to visit the My Profile section. Okay. Before downloading your offer letter, you need to go to your profile section. Now, where is this profile section? If you all could answer me. Where can you find your profile option on your LMS? Top right. Yes, correct. So you can go to this top right section where you can see your option, My Profile. My Profile. Okay. You can go there. You need to fill in all these details. You need to fill in all these details. But again, there is one point, right? So verify that your name and college name is displayed correctly as you want them to appear on the offer letter. Later, please don't tell us, ma'am, I didn't check the name, I didn't check the college name, by mistake, I submitted it. See, we cannot change them manually in your offer letter. So first thing you need to do is go to your profile section, check and verify all those given details are correct. Okay. If it is wrong, please remember, we cannot make any backend changes. It is just like a one-time opportunity for you to update your profile section before downloading your offer letter. And also there is this line given in red. Okay. Please note that once the offer letter is downloaded, the name and college name cannot be edited or altered. Is that a yes from all of you? Clear? We cannot edit it later. So the very first thing you need to do is get into your LMS, log in with your AICT registered email ID, go to your profile section on your top right corner, right? And update all those information and verify it, whether it is correct or not, whether it can go into the offer letter or not, right? And correct all of them in one go. Right? Once you click on the submit option and once you download this offer letter from here, so definitely won't be able to alter or edit it. Clear, all of you? So just check that and come back to this offer letter option and click on this download option. There you can get your offer letter. Is that clear, everybody? Yes. If it is clear, you can tell me clear. It is very simple. The only thing you need to check is like you're logging in with your registered AICT registered email ID. And if you are a selected candidate, if your student ID is there in the PDF, which we shared on the Telegram group yesterday, which means you're selected and you must be having this offer letter option on your LMS. Right? Okay. Go to this offer letter, read the instructions carefully, specifically the last line, and then go to your profile section, make sure that all those information which you have disclosed is correct or not. Then you can click on download. Once the offer letter is downloaded, the name and college name cannot be edited or altered. So these are two updates that we wanted to share with you all. Now I think I can hand over the session to Tawfiq sir. Thank you, sir. Thank you, students.
Very good evening, students. I believe that my voice is clear to everyone.
Yes, sir.
Uh,
You're audible and clear.
yes. Okay. So I'll be sharing down the screen now. Yeah. So I hope my screen is visible for you, right? Just drop your messages in the chat box. Yes. Before we start, we're gonna just take a small recap what exactly we had done yesterday, right? We started with machine learning and we were discussing about the regression problem, right? And we had solved one of the case study problem, which was given by ACME Insurance INC, right? And over here, we are supposed to find out the medical charges based on the independent variables, right? Like we had trained two kind of models, that was linear regression and random forest. I know that we had a discussion about linear regression and random forest. We were not having any update on that. Uh, so uh, in today's session, we're gonna have a discussion about more algorithms, and we're gonna use one of the classification problem statement as well, right? So that will be the major agenda for today's session. Okay, just let me show you how exactly that problem statement had been worked. So let me just try to execute the code cells here. So we had downloaded a data set where we had the age, gender, BMI, children, smoker region, and the column called charges. And charges was our target column, and other columns were our independent data, right? So based on the factors, we had to predict what is the medical charges a person is having annually, right? So we had explored a few analysis from the data, which means we had created few graph charts. We have understood the data very well. In yesterday's session, we saw the distribution of the age, we saw the BMI, then we also understood what is the charges smokers and non-smokers are bearing out, and we saw the distribution of the smoker as well, how many are non-smokers, how many are the smokers. Then we also saw the correlation between them. We check the different what we can tell features with correlated values, such as we compared age with charges, whether it is how exactly it is related, right? And in correlation also we had discussed three things. One is perfect positive correlation, strong positive correlation, and weak positive correlation. And this is nothing but no correlation here. And similar way, we have negative correlation as well, which is having the higher value and getting it decreased as well, right? Yes. Then we also created a linear regression model. Directly, let me land to the linear regression model where we had created out. Just give me a minute. Yeah, here. To create a linear regression model, what we had used a library called sklearn, which is scikit-learn basically. And from the scikit-learn library, we created a linear model and we imported linear regression algorithm, right? So then we have created a variable called model, and we have initialized an object of linear regression. And then what we are trying to do, we are separating out the inputs and targets. Now, if I need to train my model, I need to give the data, right? So I'm just creating the inputs and the targets so that both the things can be given for the training purpose and to take out the predictions of that. So I'll be using model.fit method to teach my machine. I'm passing the inputs as well as the targets. Once my machine is learning each and every factor, and I can just randomly take out the predictions here. What I have to do, I have to just use model.predict, and I have to pass all the values in the form of array. Then it will give the prediction for us. Now, basically, you can see that for the age 23, your model has predicted a person can bear up to like $4,055. For the age 50, a person is having a medical expense of 11,271, etc. Okay, so that is how you can just take out the prediction for single variable. So we compared with the single variable, and we can also do it with the multiple variables. There was some error here, probably. Okay, we'll directly go over here. Yes. So here we go. You can see that we have taken out three different columns now. One is age, BMI, and children, and we are checking out with the charges column. This will become our target variable, and this will become our independent variables, input data. And what kind of model we are fitting? We are fitting the model is nothing but linear regression, and directly we are trying to fit the input and targets in the same code cell. Then we are just generating the predictions for that. You can see I'm using model.predict, and I'm predicting all the inputs. Okay. And all those data is being stored in the variable called prediction. Then we are just taking out the RMSE value of the predictions here. So what is the RMSE value we are getting? We are getting the RMSE value of 4,608. Now, this is not only the loss function we can use. We have other loss functions as well. So I want you to post your uh, uh, what answers in the chat box. What are other loss functions we can use here? Yes, MSC. Apart from MSC, can you elaborate what exactly is MSC? What do you mean by MSC? Mean squared error. Yes, exactly. So we have mean squared error, and we have MAE as well, which is also called as mean absolute error as well. Right? Yes. So this is how we can just generate the outputs here. Okay. So we have not generated the output. We are just taking out the RMSE value. So I'll just encode all the values. Like previously, we have seen how to do the encoding, where I have converted categorical data into the numbers, right? So if you have attended yesterday's session, you might have understood how to change the values here, encoding technique. One was label encoder, and one was one hot encoder, right? Yes. So basically, I'll show you what is that one hot encoder here. So in the one hot encoder, we'll be having few values here, cat A, cat B, cat C. So basically what one hot encoding does, whatever the values you are seeing, those becomes the column names in the data set. So if the column names are being updated, and in the existing data, if the value is cat A, in the position of category A, the column, there will be a value assigned called as 1. And for cat B and cat C, there will be zeros. So simultaneously, it will repeat for each and every value. That is how one hot encoding works. Okay. And you can see this is how you can apply one hot encoder here. Basically, first you have to use sklearn library, which is scikit-learn. And you're using the pre-processing technique over there. And you are calling out the object called one hot encoder from the pre-processing technique. And you're trying to fit the data here. What you are trying to fit from the medical DF, from the entire variable where you had the data, you are picking one column called as region. And you are trying to fit that specific data into the encoder. And once the encoder is been fit, you can transform the values. And this is how your transformed values would look like, right? I think I had executed this cell here. Okay, let me run this. Yes. Even this I had executed, I believe. Yes. Okay. So we tried with the linear regression model yesterday. and we were having the RMSE value of 6,400, right? Simultaneously, we also used one of the algorithm called as random forest regressor. Okay. To use that random forest regressor algorithm, you just have to use scikit-learn.ensemble technique, and you have to use input random forest regressor. Okay. Everything remains the same thing here. You'll just choose inputs and the target. And what are the inputs? You can see these are your inputs. You are taking the age, you are taking the BMI, children, gender code, then smoker code, northeast, northwest, southeast, and southwest. Okay. So basically, if you have, we had a column called region, right? I'll show you how exactly you can use this. Let's believe that I need to predict something here. So let me just pass the random data. What I'll just do is I'll just use model RF, which means this random forest model what I have trained. Okay. So what I'll be doing, I'll just use the predict function. Okay. And what exactly I'm trying to predict here? I'm predicting the value. So basically, I'll give the age value here. Let me give the age something called as 58. Okay. I can pass whatever the values I want. Okay. It's not fixed that I have to use the same values. Okay. It's up to me what values I need to give. Okay. So I'll be giving the age value as 58. BMI, let us give somewhere around 37. Children, I'll make it as 0 children. We have the gender code here. Okay, gender code, basically we had two values, 0 and 1. Okay, so 0 basically it was female, 1 basically it was male. So I'll just give 0, which means it is a female. Then again we have something called smoker code. Even in the smoker code, we had 0 and 1. So 0 was non-smoker, 1 was the smoker value. I'll just give 1. Then we have the region. Northeast, I'll give 0. Northwest, I'll give 0. Southeast, I'll give 0. Southwest, I'll give it as 1. Okay. Now, these are the values what exactly I need to predict out. So, I'll just close up all the values and I'll just try to run this. And once I execute this code here, once I put all the values and if I just run the code here, now you can see your model has predicted that this is the medical charges what the person will be bearing. Okay. So based on the values what I have provided, your model is telling a person can have the maximum medical charges up to 48,281, and it is the dollars. Now, can you just tell me why we are getting huge value? Because there was a higher correlation with the smoker code value, right? So once I just change the smoker code value, see here, smoker code 1 basically means he's a smoker. Now, what if I just change the value to 0 here? Now, I'm making the person as non-smoker. Entire thing I'm keeping the same constant values, and I'm just changing only the smoker value. And if I just run the code now you can see that huge decrease in the medical charges. You can see this time your model is predicting based on the values what I have given, a person can have the medical charges of 13,277. And even the age matters. Now, if you just give the age somewhere around 19, and if you just change the BMI value of 24, and if you try to run, now you can see there is a again decrease. Now it is telling that only $1,738. See how marginally your model is predicting the values, right? So it is understanding the pattern from each and every form. Okay, even the age matters, right? To as you cross your age, if you are crossing the age like 50 or 60 or something, the medical charges might increase. Even the BMI as well, body mass index, which means if you have the BMI value which is more than 30 or something, if you are too fat, even that may cause in the what affecting the medical expenses. That is how your model is predicting. I believe that everyone have understood how to test it out, right? Is it understood? Yes. Post your comments. I'm still waiting for others to reply. Yes, students? Yes. Okay. Now, as we have covered this specific problem statement, we'll just go with another problem statement now. Okay, I'll just come to the PPT now. Okay. Yeah. So now we are starting up with the another problem statement with the classification problems. Okay. So we had discussed two type of supervised learning problems. One was the regression and one more was the classification. So guys, can you just tell me what is the difference between regression and classification? Can you post your message in the chat box? What is the difference between regression and classification? Yes, regression stands for the continuous values, continuous numbers. That is what we did in the last example, right? Last project, right? Regression means we were predicting the medical charges. If you have seen that, I had shown some array value, right? So we were predicting the charges. We were predicting the medical expenses of that person based on the data. And what about classification? Now we're going to do the classification, whether a person is male or female, whether a person is good or bad, yes or no, etc. Right? Yes. Okay. In classification model also, you can just have a look here. We'll be having some training data. We'll just take out and understand the feature and we're going to extract that. We'll do a lot of pre-processing to that. And after that, we'll send that entire clean data for the machine learning algorithm. And we'll select your model will give some accuracy or some output. Again, you will check your model, like what exact your model has given the response. You have to evaluate, right? You will just check what exact output your model has given. If your model has given some wrong outputs, you have to again do some evaluation. You have to improve your model. Okay. So the procedure again follows to the algorithm. Again, you have to do some changes. Again, the thing will be passed to the model. Model will give the prediction again. So that is how the continuous uh, what workflow will work for the classification model as well. Okay. So now we are starting up with the algorithm such as logistic regression. Now this logistic regression is mainly focused onto the binary classification problem statement. Okay. Now you might be thinking that why exactly logistic regression is used for solving the problem statement similar to classification, right? There might be a question, right? The name is logistic regression. It should solve regression problem, but instead it is solving the classification. Why? There might be a question in your minds, right? Because let me just tell you a scenario. Your logistic regression model, okay, it will follow the pattern and the rule of linear regression. Okay. So after implementing the linear regression formula, your model, there is a concept called sigmoid function. Okay. After taking all the output from the linear regression, after taking out the probability value, okay, their sigmoid function will get involved. Okay. There is a certain formula to calculate the sigmoid function, that is 1 divided by 1 plus e power minus z. So this is a specific formula where you can evaluate your sigmoid function. This is how you can work with the sigmoid function. Okay. The formula what we had used in the linear regression, the same formula will be used in the logistic regression as well. And along with that, there's a concept of sigmoid function. Sigmoid function will be what evaluated here. And there will be a two partitions would be created. You can see the breakup here, like how the red line is breaking between the data points. It's because of the sigmoid function. Okay. Your sigmoid function will range the value from 0 to +1. Okay. So your sigmoid function will give the value from 0 to +1. And from 0 to +1, there will be two partitions which will be done. 0 to 0.5 will be one specific group and 0.5 to +1 will be another group. Okay. Let's believe that after evaluating each and everything, your logistic regression model has given a probability value of 0.4, which means it is 0.4, which means from 0 to 0.5, it will consider as one specific criteria, and 0.5 to plus 1, there will be another specific group. Okay, that is how your logistic regression model will choose the values. Okay, so there are multiple other algorithms also where we can, we'll be using in the classification problems. We're gonna see in a bit now. There's another algorithm which is also called as KNN, K nearest neighbor. Okay. Now, by seeing the image only, you can easily understand how your KNN algorithm is working, right? So KNN is another algorithm mainly used for the classification. Okay, for classification tasks. Now you can see that we have two different charts, before KNN and after KNN. Okay, the name itself, it tells K nearest neighbor. What is KNN? KNN is K nearest neighbor. That's nothing but your KNN is. Okay. Now let's believe that we have two different categories. Okay. Category A and category B. Let's believe that all the category A is nothing but your apples, and category B is nothing but your oranges. Okay. We have two different categories, cat A and cat B. Okay. Now let's believe that a new data point is coming into the chart here. Now you can see there is a new data point, dark blue color. Now, after entering to the data, what your KNN algorithm will do? Your KNN algorithm will fetch which is the nearest neighbor for that new data point. Okay. So if the data point is near to the category A, that means the new data point, what it is been came now, that will belong to the category A, which means it will come for the apple side. Okay, or else if the data point is near to the category B, okay, the category B will be taken for the new data point. This new data point will be considered as it's nothing but a category B. It will check which is the nearest neighbor. Whichever the neighbor is near to that specific new data point, that will be considered as a specific group of that. Okay, understood how exactly KNN works now? Any doubt in the KNN? Yes. Okay. There is another algorithm called as decision tree. See, students, understand one thing, like mathematically we cannot derive right now, because if we derive mathematically, there is a lot of intuition what it is been involved. Okay. So I'm just explaining the overview how exactly that algorithms work. Okay. So if you go manually by evaluating each and everything with the mathematical steps, it may take too much of time as well. Okay. But if you are willing to do so, yes, you can go ahead by defining mathematically as well. Now we are talking about one more algorithm that is called as decision tree. Okay. Now in the decision tree algorithm, you can work on both the problem statement. You can work for classification also, and you can work for regression also. Both the thing is also fine. Okay. Now there might be a question like how exactly this decision tree will be working, right? Now let's take a simple example and try to understand how this decision tree will be working. Okay. Now I'll just give a simple problem statement for you. How to understand this decision tree. Now I'll just take a example stating that there is a person who has given an interview in one of the company. Okay. And after the interview, the company has given some what salary, some X amount of salary to that person. Okay. Now, based on the factors, you have to create a machine learning model to predict can that person accept the job offer from that company, or can the person reject the job offer. Okay. Now, the problem statement is simple. Okay. You have to create a model in such a way that your model should predict based on the data, whatever you are giving. whether to accept the job or to reject the job. Okay. Now the first feature or the first decision, let us see what your model will be asking as a form of data. The salary. Okay. Now, if the company is giving 50,000 salary for that person, okay, your model will check whether 50,000 salary is acceptable by you or it is not acceptable. Okay. Your model will check previous data. Now, how your model will check the previous data? So previously, what exactly was your salary from the previous company? If your previous salary was 30,000 and this company is giving 50,000 salary, what your model will do? Yes, it will accept the offer and it will check the next decision. Okay. In the next decision, your model will again check whether the office is near to your location. Okay. If the office is like around 20-25 kilometers, 30 kilometers, yes, again it's gonna accept the job. If the office is like 1,000 kilometers, 1,500 kilometers, like in other states, what your model will do? Directly it will go for the rejection. In the second decision only, your model will tell no, we have declined the job. Okay. Now if your model is accepting the second decision also, whether it is 20 or 25 kilometers, your model will check with another decision whether the company is giving the cab facility. Okay. If the company is giving the cab facility, yes, you're going to accept the job. If the company is not giving the cab facility, you're going to reject the job. So that is how multiple decisions will be taken out. And finally, your model will come to the conclusion whether to accept the job or to reject the job. Okay. So that is how your decision tree will be working. Clear? Students, have you understood how exactly the decision tree will be working now? The workflow? Yes. Cool. Okay. We're going to discuss one more algorithm, that is random forest. And after this algorithm, directly we'll land into the problem statement. Fine? Yes. Now, can anyone tell me like how exactly the random forest will be working? I just want to understand how much you are aware about random forest. Yes. Random forest. Combining multiple decision trees. Yes, good. Group of decision trees. Ensemble technique. Okay, good. Combination of multiple decision trees. Combines. Okay, nice. Okay. So by seeing the chart, you can easily understand how exactly random forest will be working. And in yesterday's problem statement also, I had clearly told that random forest algorithm is considered as one of the powerful algorithm in machine learning, right? Yes. Okay. Now let's believe that we have a basket and in that basket we have a whole bunch of fruits. Okay. Now I need to create a machine learning model in such a way that based on the fruits, your model has to uh, guess or predict what exact fruit it is. Okay. Now to do that, what your random forest will do? Random forest will call 100 random trees. Okay. No, it is not fixed that your random forest will pick 100 decision trees. No, it is not true. You can also change the number of decision trees, how much you need to give it. Okay, you can change the decision tree values, like how many decision trees need to be participating to give the solution. Okay. Now, what happens? Now, once I give the random forest model, okay, by default, your random forest model will pick 100 decision trees and it will tell uh, all the 100 decision trees to give the predictions. Okay. Now, based on the data, your decision tree number one, it will predict the fruit what I am giving the data of. It is nothing but an apple. Okay. Second tree, again, it will give the answer as an apple. Tree number three, it will tell it is a banana. Tree number four, again, it will give as apple. Tree number four, again, it will give some other answers. Okay. So likewise, all the 100 trees will give 100 different answers. Okay. Now, after taking all the 100 answers from the entire decision trees, What your random forest model will do, it will check the majority voting. Okay. Now, in the majority voting, there will be a conclusion that for the apple, there is 91 votings, and for banana, there is only 5. And for other these things, there are only limited votings. Okay. Now, what your random forest will do, it will tell that whatever the majority voting, whatever the output they are getting, whatever the prediction they have got, that will be considered as the final output from the random forest. So that is how your random forest will work. I believe that you have understood the concept behind the random forest now. Is it a yes? Yes. Good. Okay. So what we can do is, these are the performance metrics for regression and classification. Yesterday we had a discussion, right? In regression, you can use MAE, which is mean absolute error. Then we had MSE, which is mean squared error. We had one more RMSE, which is root mean squared error. Then R squared, we have adjusted R square, mean absolute percentage error. So these are the performance metrics for the regression. So yesterday we had used RMSE method, okay, to check the evaluation of the model. Okay. So in the classification, we have multiple things. Okay. For the classification, a few companies will be completely relying on the accuracy score, sometimes balanced accuracy, precision, recall, a negative predictivity value, F1 score, and correlation coefficients. Okay. So these are the different performance metrics, what you can do it for the classification. Okay. So if you want to use multiple different performance metrics, you can choose it and you can just finalize. Okay. But after all, there will be a stakeholders, what they will be requesting, whether they want the recall score or the accuracy score or F1 score, etc. Okay. It's dependent on them. Okay. Whatever their requirement is, you have to make that those values to be in a higher rate. Okay. So if you just take an example, for precision, there is a separate formula. For recall, there is a separate formula. For F1 score, there is a separate formula again. That is how it goes. Okay. So we have a problem statement here. We have two problem statement. One is classification of the text, and another problem statement is auction car purchase is whether it is a good or a bad. Okay. So there are two different problem statements. Okay. So we can just work with one simple problem statement. And again, I'm going to show you the data, and we'll understand the data first so that we can do the modeling much better. Okay. So to save the time, like I have written the documentation for your purpose as well. Okay. So I'll be explaining all the stuff here. Okay. Entire thing I have just written. We just have to execute the code set, and the dataset link is also being given. You can download it and you can just test it out here. Any doubts before we start? Shall we start the practical implementation? Yes. Is it a yes? Okay. A few people are asking where to get this project links, right? You can just find it in the LinkedIn profile. Sorry, not the LinkedIn profile. Sorry, the Telegram group. Okay. And the GitHub links also will be provided. Okay. So if you are having some good idea about this, yes, obviously you can start working on your projects, and you can just submit your projects. Okay. The deadlines would be given out. Okay. So the updates will be given out in upcoming days when to submit this. These are just the part, like how you can just work on AI projects about machine learning. You can get the data set from the Kaggle website as well. Yes. Shall we start? Yeah, only one project is fine. Any one project which is related to artificial intelligence, it's fine. Shall we start the problem statement now? Yes. Okay. The title name is, you can see that, don't get kicked. Okay. Now there might be a question like why we should not get kicked, right? Now let's believe that there will be a lot of vehicles which will be coming towards the auction. Okay. Now when the auction is being taken place, what happens is there'll be people who will be bidding out, right? So if there is a vehicle, let's believe that the vehicle is of Chevrolet. So there will be a certain price. Okay. So people start bidding for that. Okay. So once the bidding is being done, after the vehicle is after the vehicle is sold to the customer or the person. Okay. So he is not having an idea whether a purchase is good or a bad, right? In the situation, he'll just make a bid, right? And after doing a bid, he has no idea whether the vehicle uh, is good or bad. To make a conclusion, to predict that one, okay? So we are creating a model to predict based on the data of the vehicle. We can easily predict whether the vehicle is good or a bad. Okay. So we'll just understand more precisely now. Okay. So let me just read out the entire documentation first so that you can understand much better again. One of the biggest challenge of an auto dealership purchasing a used car at an auto auction is the risk of that vehicle might be serious issues that prevent it from being sold to the customers. That is one of the what biggest challenge, right? In the dealership, like if a person is purchasing a car, he's not sure how well the vehicle is being maintained. Okay. So basically whatever the vehicles they sell, they call it as kicks over here. Okay. So kicked cars are often result when they are tampered odometer, mechanical issues. The dealer is not able to address issues with getting the vehicle title from the seller or some other uh, unforeseen problems. Okay. So based on this specific data of the vehicle, we have to evaluate whether the vehicle is based on the price or allotted whatever we have taken out, whether it is a good purchase or the bad purchase. Okay. So mainly we have to predict whether a purchase is good or bad. So what kind of problem statement it is? Can you just post your messages in the chat box? Post your comments. What kind of problem statement it is? Yes, exactly. It is classification. We are classifying whether a car is good or bad. Okay. Now, this is a real data and there were 150,000 customers. Okay. And based on the historical data, what we have collected, we are building a self-automated system to predict of the car details and to predict whether a purchase is good or a bad, so that it might be helpful in the upcoming auctions. Okay. Now let us understand the description about the data. Now entire columns I have mentioned it out, but if we just go uh, uh, by understanding each and every column, it may take some amount of time, but I'll make it quick. Okay. We'll just highlight only few columns which is really important and which is more understandable. So what we're going to do is, so these are the column names or the features we can call. Okay. That is, one is the reference ID. See, whenever the new vehicle is coming, one of the what unique ID will be generated, right? Such as the serial number. So that ID will be taken out. And then we have another feature called as is bad buy, whether the purchase of the vehicle. This is the column what we are trying to predict, whether a vehicle is good or bad. Let us see in the data what values we have. Then we have purchase date. This is a column. Okay. When the car was purchased, then we have the auction. So auction provider at which the vehicle was purchased, in which auction the vehicle was purchased, those kind of value. Vehicle year, the manufacture year of the vehicle. Vehicle's age, again the same feature, what is the age of that vehicle. Then we have another column called as make in the sense who is the manufacturer, whether it is Honda or Chevrolet or some different thing. Then we have the model. We have the models, like based on the models, your model can evaluate. Model in the sense like whether it is if you take uh, Honda, we have Civic, we have Accord, different kinds of cars, right? So similar kind of things. We have vehicle trim level. We have submodel, color, transmission, wheel type. So these are the different factors what it is involved. So based on these factors, what we have to do, we have to create a model where easily I can predict whether a purchase of the vehicle is good or a bad. Okay, this is my problem statement. Okay, so instead of taking out each and every what column name, so directly we can highlight what are the main columns to be targeted. You can see we have what are the types of vehicles odometer is there, where we can get the readings like how much kilometer is being driven. Nationality, where exactly what is the origin where the vehicle was manufactured. Size, basically how many people can sit in that vehicle. Then lot of things are available. Okay, acquisition, auction, average price, then again clean price, average price, lot of other factors are also available. Okay, then kick date, then we have unique number assigned to a buyer that purchased the vehicle. Okay, a lot of things are there. Then we have vehicle cost, what is the costing of that vehicle. Okay, whether it is a online sale or something, warranty cost is there or something. Okay, a lot of factors are involved in the data set here. Okay, now this is the outline of a project. First we'll install the required libraries. Okay, you can also download the data set from the Kaggle. Okay, so I've given the link directly, or else there is a downloaded data set file which has been downloaded with us, and which I have attached in the GitHub link over there. You can directly download the data set from there as well. Okay, now you can see these are the libraries what we are using. Okay, now I'm using one of the library called pandas for analyzing and cleaning the data here. Then we have numpy library for numerical computing, matplotlib for creating the visualization, again Seaborn for the visualization. Now there is another library called open datasets. Now open datasets is another library where you can download the data uh, from the online platforms. Okay, let's believe that I have a URL. Okay, I have a URL link where the data has been located, and suppose if I need to download that data set from that URL, I can use this open datasets library. Okay, I can also use import OS. Okay, it's optional. If I'll just erase that. Okay, then Plotly Express again for advanced visualization. Okay, so I'll be executing this. Now you can see that my code cell got executed. Okay, all the libraries has been executed now. Now this is the URL link where the dataset is available. Okay, I can just execute the code cell, and you can see that in that specific folder, don't get kicked, there are these many files. Okay, so in the Kaggle, if I just directly go for od.download, the dataset would be downloaded, and there's a folder called don't get kicked, which was downloaded from the Kaggle, and there are bunch of files here. One is training.csv, where the entire training data is available. Okay, then we have Carvana data dictionary, which is the text data which has been written. We have the zip file, we have the test data, and example entries as well. Okay, so as of now, we'll just focus on one specific file, that is training.csv, and let's see what values we can just find out in the training CSV file. Okay. Now what I'll be doing is I'll just take the variable called train.df. Okay, in the train.df, I'm just reading all the data. Okay, now you can see that I'm using the pandas library to read the CSV file, and this CSV stands for comma separated values. Okay, I'm reading out the CSV file here. Folder is don't get kicked, and the file name is training.csv. This is the file what I'm reading out here. I'll just run this. Now, once I do that, now you can just directly check the variable name called trained.df. Now, if you just execute here, this is your training data here. This is your trained.df. Whole bunch of data is available here. Now you can see that in this data, we have 34 different columns, which is also already mentioned in the data description, and 72,983 entries or records. Okay, you can call it as records or the entries or the rows as well, right? So for each and every entry, there is a specific reference ID which will be given out. Okay, then we have a column called is bad by. Now in this is bad by, we have two different values. We can just cross check that later on. Okay, we have the value called 0 and 1. Basically, this is a column what we are trying to predict whether a purchase is good or a bad. So 0 basically means it's not a bad buy. 1 basically means it is a bad buy. Okay, then we have purchase date and auction, where exactly the auction was held, vehicle year, and what is the age of that vehicle, and what is the make of that. So the vehicle is nothing but Mazda here. The model is Mazda 3. Trim we have, submodel. Lot of other different columns are available. Okay. So let us understand the summary of the data. If you want to understand the summary of data, again, we have a keyword called info. In yesterday's session also, we had understood what is that info keyword does. It gives the summary of the data. Now here we go. Now you can see that the reference ID is available in the form of integer data. Okay, is bad by, basically it is an integer data again, where we had the values 0 and 1. We had purchase date. Basically it's an object, which means it is a string value. You can see it's not date time. Basically we have slash in the data. That might be a reason that it is containing as an object. We need to do the pre-processing here. We need to change the data type of this so that we can train the model. Okay. Then we have the column called auction. Again, it is the string value. So likewise, we have whole bunch of different data types. Okay, we have vehicle age, make, model, trim, submodel, color, transmission. Okay, wheel type, then odometer, nationality, size, etc. Okay, so I believe that everyone have understood about the data now. Have you understood what is the exact problem statement? Just drop your comments in the chat box. Are we good to go? Yes. Nice. Yes. Okay. Now, similar way, we have created two different files. One is the train data and one is the test data here. Okay. So test data basically will not be having that column, which means what exactly we are trying to predict. Basically, it's just for the testing purpose. Okay. So as of now, we'll not concentrate on this. We'll just focus on to the training data here. Okay. Now, to understand EDA, like I've already told in yesterday's session that if you want to build any machine learning model, right? First, you have to understand the data very well. The better the data you get, if you understand the data very well, creating a chart, creating a machine learning model is much easier. Why? Because you'll be having some sort of idea what is happening in the data and what exactly the values are available. Okay, so you have to make sure that whenever you start with machine learning part, okay, you have to spend like around 60% for EDA, exploring the data and doing a lot of pre-processing inside that. Okay. Yes. Now, what I'm doing is I'm taking a variable called A, and inside that I'm just using the train data where I'm picking a specific column, whether it is a bad buy, and I'm just checking the value counts of that. I'm just checking what are the values available in the bad buy column. Okay. And I'm creating a chart of that. Okay. That is what I'm trying to do in this. Okay. So here you can see that. So basically it is telling that, okay, wait, we need to run the code again. SNS dot bar plot x equal to no s. We'll wait. Why the chart is not coming? Okay, we'll just wait. If not, we can just create another chart and we can just plot it out easily here. Okay. The same thing. What we have to do is we can just display the values directly here. Okay. Now you can see that among the data set, there are two kinds of values, that is 0 and 1 basically. Okay. In that 0 and 1, there are 64,007 times which is repeated for zeros, and 8,976 times one is been repeated, which means almost out of, like, what was the count of the data here? Out of 73,000 vehicles, there are approx 9,000 vehicles which is going for the bad buy, right? Understand the problem statement here. See, out of 73,000 vehicles which came for the auction, there are approx 9,000 vehicles which is going for the bad purchase, right? And hardly like almost like 64,000 is going for the good purchase. Okay. So we need to design a model in such a way that we will be getting a prior idea whether the vehicle is a good purchase or a bad purchase, so that it can be auctioned in the future. Okay. So that is what our aim is. Okay. There might be some error in creating the charts, I believe. Let me just check the kernel first. Okay, it's fine. If the chart is not created, like manually, we'll just create a chart again. Okay, to understand what's happening here. Okay. Again, here you can see that from the training data, again, we have taken out the auction and we are checking out the values here. Okay. So we'll just try to check out the values here. Okay. So basically, auction is being conducted in three different places here. One is the Mannheim, other, and Edessa. I'm not sure whether I'm pronouncing it right or wrong. Okay. So I could have shown the chart, but due to some, I think, issues, the chart is not getting plotted here. Okay. No worries. You can just directly apply the plot function here. And you can just give kind equal to pie chart, where you can just manually create the charts here. Okay, there might be a problem in the kernel. That's the reason the charts are not getting plotted. You can see the axes are getting displayed and the plots are not coming. Okay, so no worries. If you run the code, you'll be getting it out. It's just error from my side, not an issue, but you are getting the insight here. You can just get a data frame here. Here we go. Like in the column called auction, so there are basically three different places where the auction is going to be taken place. One is the Mannheim, other, and Edessa, and out of which Mannheim is taking the top spot, which has sold 41,043 cars in that auction. Okay, so same thing goes here as well. Just let me, yeah, where did that go? Here. Again, let me just check this out. I'll just take the variable called make here. Okay. Now here, you're seeing what kind of values, what kind of vehicles came for the auction. Okay. So I have sorted all the values. You can see the entire function. I've written it out over here. See, I'm taking the entire data. From the entire data, I'm picking a column called make, and I'm checking the value counts of that. Okay. And I'm creating a data frame of that specific column. Okay. Now you can see that Chevrolet, basically this is a specific make, the company. Okay. And there are 17,248 vehicles belonging to Chevrolet. Dodge, approx 13,000. We have the Ford vehicles as well, which is going like 11,305. Then we have, I'm not sure like how to pronounce this. It's believe Chrysler or something. It which is almost having 9,000, and Kia of 2,484. Saturn, Nissan, Hyundai, Jeep, Suzuki, Toyota. Okay, so this is how we can just check out the values as well. Suppose if you just want to check top 10 values or something, you can just use the pandas function to do that. That is, you can just use the head function, make dot head. You'll just get top 10 vehicles which is belonging for the make. Yeah. Okay. So that is how you can just understand here. Okay. Again, I'm just checking out the distribution. Okay. So I'm just checking the vehicle age and whether it is a bad buy. Now you can, by seeing this chart, what can you assume? Okay. Understanding the histogram also I had shown you yesterday, right? I believe. By seeing the chart, what can you understand? I want your response, students. Look at this specific histogram. What can you understand from this? Okay, so few people are telling we can analyze it easier. Like how? By seeing the chart, what are you able to understand here? Count of the vehicle age, okay, acceptable. That is one thing. Apart from that, okay, we can also check whether it is a bad buy or a good buy or something, right? And we can have a count like what sort of vehicles or what age of vehicles has been sold a lot. Now, if you just take a consideration here, uh, the height or the more number of count, it is going for the vehicles age 4 and 3, right? So you can have a look here. The age of the vehicle, it is in the x-axis, and in the y-axis, we have something called count of the vehicles. And almost like for the age 3, there are 15,000 vehicles, and again age which is crossing like 4, which is having the age 4, which is going the count beyond 15,000. Okay, so majority of the vehicles are belonging to the age 3 and 4 years. Okay, and there are few vehicles at the age of 9 which came for the auction as well, you can see here. And among that 9 vehicles, one of the vehicle is considered as the bad buy again. Okay, so no, so basically you can see here the count is 444. Okay, the age 9, there are 444 vehicles which had the age of 9 years, and out of that, one of the vehicle which is going for the bad buy as well. So that is how you can just understand each and every flow from the chart. Okay, it's not only fixed for checking the vehicle age and whether it is a bad buy. There are a lot of other things as well. Okay, you can also check with the make and is bad buy. So you can consider that. See here, uh, purchasing the Chevrolet vehicle doesn't tell that it is a bad choice, because a lot of people have purchased the Chevrolet vehicle, and they are happy with that vehicle, which is considered as not a bad choice of purchase. And over here, you can see that there are few vehicles like Mini and Subaru, or some other vehicles, which is having the reddish line at the bottom, which is considered as the bad purchase. So you should be sure at understanding this kind of criteria. It may have an impact again. And you can see the Nissan, Dodge also, right? How exactly it is going out. Okay. Then you can also check the nationality. Let's see what are the nationality we have. So basically, American vehicles are sold in the huge quantity, and top line Asian vehicles are limited. Like the count is 3221. Okay, these many vehicles. Other Asian, again, the count is 6972. Okay, there are few other what country's vehicle, which is showing the reddish line here, which is telling that it is a bad purchase. Again, we are just checking with the size and is bad by again. Okay, again, if you cross check medium vehicle, large truck, compact, large, again you can analyze each and every factor here. Okay, so whole bunch of things can be done, and uh, you can analyze each and every data here. Okay, yes. Now one more thing. So instead of like we are running out of our time, instead of understanding the data much better, what we can just do is we can directly go for the pre-processing. Okay, because there are few more things what we have to be discussing up, right? So like considering that what kind of projects you would be doing and what are the things you'll be doing to do that kind of things, I'll be directly landing into the pre-processing here. Okay, and before we do that, I just want to check how many missing values are available, and I'm just checking the sum of that. Let's see here. Now you can have a look. There's a column called trim, which is having 3.2% of the missing values. Okay. Now you might be thinking that, see, if I just remove these specific values here, I can directly get the count here. I'm getting the count here. But if you want to show the values in terms of percentage, okay, what you can just do is you can just replace one of the formula here. You are multiplying it with 100 and dividing it with the length of the data here. Okay, so if you just try to run this, you can see there is a column called trim, which is having 3% of missing values. And there's another column called prime unit, which is having 95% of the missing data. Then AUC GWAT or something, again it is having huge amount of missing data. So we would rather go ahead with dropping these columns. Okay, so in machine learning what happens is, like, if you have a huge amount of missing values, then you will be going for the dropping those columns. Okay, you'll not keep those columns. You have to keep this thing in mind. Is NA, basically you are checking whether the column is containing any null values, whether it is empty or not. To cross check that one, you're checking. It is as simple as is null. Okay, yes. Any doubts still here, students? Yes, see, basically these commands are like the pandas. If you have learned Python and pandas programming, it is easy to remember this kind of keywords. Okay, it's really simple, guys. Okay, no need to worry, those keywords are really simple. Yes. Okay, again we are just checking another column called is online sale. Okay, we are just checking that. Now in the is online sale, you can see that basically there are 1845 vehicles, which is denoting the value as 1, which means they came for the online. Okay, there were 1845 vehicles which came for the online, and the vehicles which did not land for the online is 71,138. Okay, yes. Now we'll start with the data pre-processing here. Okay, there is a column called transmission. Okay, first let us see what is that transmission column is containing again here. Let me just put it here. Okay, so in the transmission you can see there are a whole bunch of values, auto, manual, and all. Okay, so what I'm trying to do is okay, first let us check all the unique values inside those. Okay, now you can see that in the transmission column there is a value called auto, auto gears, then again manual, we have nan, which means empty, and again manual. So the manual is been repeated twice here. So to merge both the things, I'm using one of the replace function by using the dictionary method. Okay, don't get confused here. So I'll just remove this as of now here, or I'll just shift it to above cell. Okay, yeah. Now again, let me just check the is NA method, whatever we have seen that. Now, what we are trying to do is we are dropping the unnecessary columns. Okay. Previously, I had told there were a lot of columns which were containing unnecessary data, right? So I'm dropping the column called trim. It's of no use. I can drop the model as well. Okay. Uh, there might be a question why we are dropping the model, because see, we have another column called submodel. So I think submodel gives us like lot of insight compared to the model. Yes. So that is the reason we are dropping the model. Again, reference ID we don't require. Vehicle here, again we don't require that. We have some alternative column name. I think we have the purchase date for that. Then we have wheel type ID. These are the columns what we are trying to remove here. Okay, I'll just try to remove that. Now I'll try to check the describe function, which means I'm checking the statistical analysis for the data now. Now in the statistical analysis, what can you understand here? You can just get the mean value, minimum value, median, which is also considered as 50th percentile. You can check what is the maximum value, okay, etc. Now is bad by basically had 0 and 1. That is the reason you are getting these values. Okay, you can check out with the vehicle age now. So the mean, it is telling that 4. On an average, the vehicle's age is nothing but 4 years. Okay. There are few vehicles which age is like 0, which means like those cars are freshly released, I believe. Okay. And 50th percentile, which is also the median, it is 4 years. The maximum value is 9. So 9 is the oldest vehicle which came for the auction. Not only that, we have the odometer value as well. There are few vehicles which has been driven for 1,15,707. Okay. And let us see the minimum value. There was a vehicle which was driven only 5,000 kilometers approx. Okay. So that is how you can just understand the factors inside the data. Okay. Any doubts still here, students? Any doubts? Yes. Okay. Now what we are trying to do is we are dropping the column called is bad by, because we are changing, we are separating the inputs and the targets. All right. So this technique in the last session also we had used. Okay. We had taken something called inputs and the targets. If you remember, in yesterday's session, we had taken something called inputs, where all the independent variables was there, and target because becomes the dependent variable. Okay. Now I'm just trying to run this code here, and you can just check what value we have in train targets and train DF now. Okay. If you add the code cell, you can just have a look here. If you just check train targets, you'll be having only one specific column here. Yeah, this is one specific column. It is it is telling whether it is a bad buy or good buy. Okay, these values. Now, if you just check train DF, apart from that is bad buy column, all other columns will be there. Okay. Yes. Okay, I have mentioned all the steps here. Okay. Now we'll just go with the encoding and imputing technique. Okay. Now, can you just tell me what is encoding? Students, I want to listen from your side. What do you mean by encoding? I think we had a theoretical discussion yesterday. Encryption, converting categorical to numerical. Yes. Encoding is nothing but converting the values. Yes. Converting the categorical data into the numeric data. That's nothing but your encoding is. Okay. And can you tell me what is imputing? What do you mean by imputing? What do you mean by imputing? Yes, exactly. Filling out the missing values. Filling out the missing data. That's nothing but your imputing is. Okay. So I want you to remember these terms. Okay. If you want to work on machine learning problem statement, you should be having a clarity what is encoding and what is imputing. Okay. Encoding basically converting the categorical data into the numerical data. That's nothing but your encoding is. Okay. And what about imputing? Imputing means basically you are filling out the missing values. Wherever there is a missing value, you are applying the missing values to that. That's nothing but your imputing is. Okay. Yes. Okay. Now in this specific code cell, what I'm doing is I'm taking a variable called numerical column, and I'm taking the entire train data and selecting the uh, data related to the numbers. You can see I have used the function called exclude object, which means I'm excluding the object data, which means I'm not taking the categorical data. I'm taking the only columns which are specifically of the numbers. Okay. Whatever the columns are related to the numerical data, I'm picking only those columns. You can cross check here. Okay. You can check what is that variable called numerical columns. So these are the columns which is having the numerical data. Vehicle age, odometer. Okay, these are the other price values, auction price, average price, etc. Okay, so basically these are the data which is related to the numerical columns. Okay, now I'll just if you want to use the imputer technique, what you will be doing, you have to use from the sklearn, which means from the scikit-learn library, you're going to use the impute function. And what you're using, you're using the simple imputer. Okay. Now, again, what you'll do, you'll just create a new variable called imputer. Let me run this. And you'll call out the object here, simple imputer, and you'll apply the strategy. What is the strategy you're using? I'm using the strategy called as mean. I can use it the median as well. Okay. See, I'm doing it for the numerical columns, right? I have picked this numerical columns, and wherever there is a missing value, I want to replace that. So that is the reason I'm applying the strategy here. Strategy, I can either use the median or the mean. Okay. So there are factors what you have to decide mean and median. So if you are choosing the median, it will overcome the outliers. Okay. If you are using the mean, there might be a chances of getting an outlier. So you should be picking the specific uh, things more precisely. Okay. You have to plan it, and you have to what select the things accordingly. Okay. So I'll just create an object of imputer now, and the strategy is nothing but the mean here. Now what I'll be doing, I'll just create the column called numerical columns, and what I'll be doing is I'll fit all the uh, data to the imputer now. Now you can see that I have given imputer dot fit transform, and what I'm transforming, I'm transforming the numerical columns here. Okay, I'm applying the imputer technique, which means wherever there was a missing values, okay, I'm trying to fill those missing values. Okay, let me just show it again if you are getting confused here. So if you just check, let me show you here. I've taken the variable numerical columns, right? This numerical columns dot is NA. If I just use dot sum, okay. Okay, basically I had to use the data here, train df, my mistake. Okay, so there are missing values, right? Here we have wheel type, here we have 18 missing values in average price, auction price and all. So I want to make it 0 here, which means wherever there is a missing values, I need to fill out the values over there. So to do that, I'll be using the simple imputer technique, and the strategy is nothing but the mean here. Okay, now I'll just transform the values, and let us see here how exactly it is working. Now here we go. You can see that wherever we had the missing values, it got replaced, right? Now you might be thinking that why the missing values were not replaced for wheel type. Can anyone tell me like why it was not replaced for wheel type? I want your points. Yes, exactly. So you are understanding that things now. Yes, because it is an object data. We had applied the imputing techniques only for the numerical columns here. You can see here. Don't get confused here. Whatever the imputing techniques we have done only for the numerical data. And the column called wheel type has the object data inside that, and it cannot be imputed. Right? So that is the reason we applied only for the numerical columns here. Now, what we can do is, I'm just checking the fill values here. Okay. So here, if I just apply this for the categorical data, I've used value counts. Okay. Whichever the value was repeated maximum number of times, those values I'm replacing for the categorical data. Okay. We call it as a mode technique. Okay. In statistics, there is a concept called mode. Okay. Now, if you take an example, if there is a column called fruits, and out of that fruits, there are three different fruits. One is apple, orange, and mango. If apple was repeated 5 times, orange for 2, and orange for 3, the mode of that is nothing but apple. Because apple had more, apple has been taken out more number of times. So similar to that, in the column called wheel type, whichever the value was repeated more number of times, I have replaced with that specific value. This is called as pre-processing technique. Okay, so it's our choice. If you want to do it manually also, you can do it, but I cannot give the empty values to the model. That is the reason I have imputed this technique here. Okay, then we're gonna go ahead with encoding techniques. And let me tell you again, there are two types of encoding technique what we had discussed. Okay, one was binary encoding and one hot encoding. Okay, now can you tell me what is binary encoding? What do you mean by binary encoding? Yes, 0 and 1, right? So, and what about one hot encoding? Basically, one hot encoding creates the new columns, and whatever the values is being given, ones will be replaced over there, right? Okay, so that is not only the encoding technique what we will be working. There is another encoding technique called as label encoder as well. Okay, there's another encoding technique that is called as label encoder. Now, basically, label encoder gives the ranking. Okay, it gives the ranking. Let me just give a simple example. If you just take a column called graduation, what is your education? Okay, let me just take a simple example about I'm collecting a data and there's a column called education. Now, few people, what they will do, they'll fill out the data like few people have done PhD, few people have done masters, few will be having only the bachelor's degree, few people will be having something called only the high school, right? So like that, they'll be filling out the values. Now your label encoder, it will give the ranking basically. Okay, how? For the PhD, it will give the rank as 1. For masters, the rank will be given as 2. For graduation, it will be 3. Okay, or graduation is a bachelor's degree, it will be 3. For high school, it will be 4. Like that, or likewise, it will be giving the ranking. That is how your label encoder works. And for what are the columns I'm applying the label encoder? I'm applying the label encoder for the column called auction, transmission, wheel type, nationality, top 3 American name. For these specific column names, for these columns, I'm applying the label encoder. To apply the label encoder is also very simple. You can see from the sklearn scikit-learn library, I'm importing the pre-processing technique, and I have created a variable called label encoder itself, and I'm applying pre-processing of label encoder. Okay. Then again, I can just fit underscore transform. I can apply this function and I can just give the column name what I need to transform it. Okay. So this is the easiest Python function what or the Python code. You can just use it for converting the values. Okay. Now let's just before we start, student, just let me know, have you understood the label encoding here? The flow of label encoder? Is it a yes? Yes. I'm getting a lot of yes. I want others also to volunteer here. I want you to put your response here. Yes. Good. Okay. Now I'll just execute this label encoder, preprocess label encoder here, and let me transform the values. Now let me just check the train data and of head here. Okay. Now here we can see that we have a column called auction. Now previously in the auction, we had some different values, right? So I'm not sure what values we had. I need to scroll up and cross check again what values we had. I'm scrolling up and checking out what values we had in the auction column. Okay, now you can see that auction had the values called ADESA or some different values, right? Now once I apply the label encoder function here, where is that? Here. Once I apply the label encoder, the auction column got converted, and we have the numerical values. So I'll just give the value also here. Wait. Yeah, I'll just give the value as 10 here. Okay. Now you can see that whatever the values were available, so it got replaced. I'll just pick some random values so that multiple values can be shown. So I am just using the sample function. Okay, you can see now in the auction we have values like 1, 0, 1, etc. Right? Then what is the next column? We have applied label encoding transmission. Yeah, even transmission also is being changed here. You can see the values got converted into the numbers. Wheel type, again it was changed. So likewise, this is how your label encoder works. Okay. Yes. Similar way you can apply the one hot encoder as well. Okay. So one hot encoding, like I have already told you how to apply the one hot encoding. Now take an example. If you have a column called as transmission, and if the value is transmission A, transmission B, transmission C, okay, those transmissions will be created a separate columns. Okay, and out of which, if the value is repeated called cat A, for it will search for the column called cat A, it will give the value as 1, and for cat B, cat C, it will give the value as 0. Okay, in the next row it will see which is the value. It is cat B here. For cat B column, it will come and it will give the value as 1. For cat A and cat C, it will give the value as 0. Okay, so likewise it will work. And similar way I have taken out the categorical columns as well. Now let us apply the one hot encoding here if requires, or else I have commented out the things. If you wish to go ahead with only with the label encoding, you can go, or else you can go ahead with the one hot encoder as well. Okay, for an one hot encoder, yesterday we had taken an example. We applied for those technique. Here also, if you want to implement one hot encoder, you can, or else you can stick with label encoder. It's your choice. Okay, but you have to think wisely why you are using one hot encoder, why not label encoder as well. The next technique is scaling down the data here. Okay, so scaling down the data basically means you are reducing the values. Okay, so for an example, there are few columns which is having the values like 0, 1, 0, 1, etc. Right? And there are few columns which is having the high amount of value like 50,000, 60,000. So if you compare two columns, there is a huge deviation in the values. One column has the higher range value and one column has the really small tiny amount of value. So if you scale down the data here, if you scale down the data, what happens is it will range the value from 0 to 1. Your machine will understand much better. Okay, so it will help you in what making your model more efficient. Okay, or you can also tell it as you're optimizing your model. Okay, to apply the scaling technique, I'm using the min-max scaler. Okay, and that you can get it from the scikit-learn library, again from the preprocessing library. Okay, so you'll just run this. You can apply the min-max scaler. Their functions are really simple. The same way what we had used for other function, similar way you can apply for this kind of data as well. Then again, you can transform all the values. And after applying the scaling method, this is how your values would look like. You can see vehicle age, the maximum value it is reaching up to 1. And what is the minimum value? It is 0. The value has been marginally reduced. It is not only for vehicle age column, it is for odometer also. You can see the maximum vehicle is driven as 1. And what is the minimum? It is 0. It has compressed the values. Don't think that it has removed the values. No, it has not removed the values. It has compressed the values. Okay. It has scaled down the values so that your model can work more precisely. Okay. Your model can learn more efficiently. You can also drop these columns again. Why? Because you have created alternative columns for this. Then after that, again, the new thing starts. Okay. There is something called training, validation, and test. Now, can you tell me, have you heard these terms before? Training, validation, and test. Yes. Good. So basically, training is nothing but the data, what we are using it for the training purpose, right? That is one thing. And what about validation? During the training process, suppose if you want to optimize our values, if we are evaluating, if you are checking out, that is nothing but your validation. And testing is nothing but after creating your model, if you are testing how your model is working, basically you can give it the testing procedure. So either you can just go only with training and testing, or you can also include training, validation, or test. It's up to you. It's your choice. Okay. Now to use that technique, we are using a simple function here. Now you can see from the sklearn model selection, we are importing train test split function. So this is another train test split function from the scikit-learn library where it splits the data equally. Okay. So whatever the data you want to be split, you can split the data equally here. Okay. Now I'll tell how exactly you're splitting the data here. First, you're gonna import this. Okay. Now you are creating the variables. You're creating the inputs. You're creating the validation inputs, and you're creating the train targets and validation targets. Okay. So you are using this 4 different variables now. You can also consider this something as inputs, sorry, train inputs, and this is nothing but what test inputs. Here, train targets and test targets. You can use it whatever you want. Now you are using the train test split function, and out of which you are passing the train data and the targets as well, the inputs and the targets, and you are giving the size of 20%. You can see the test size I have given as 20% and initialize a random state equal to 42, where it can choose the random values to select the model. Okay. Now let us create a dumb model. Okay. Before creating a dumb model, you can see this is a matrix what we'll be using. One is the accuracy score and the confusion matrix. Okay. This is the evaluation matrix what I'll be using for this project now. Okay. Accuracy score will give the accuracy for me. Like what is the accuracy based on that? Okay. And confusion matrix basically gives like how your model is behaving or giving the right answer and what about the negative answers as well. Okay. Okay, this is the dumb model. In the dumb model, you can see that randomly your model is predicting 87% of accuracy. Why? Because a lot of zeros are available. Okay, let's not focus on to the dumb model. Directly we'll come to the logistic regression and let's see how our logistic regression model will give us the output now. Okay, so logistic regression model, we had a understanding. Basically, it is used for the classification problem statements. And apart from that, it uses a linear regression formula and followed with the sigmoid function. Okay. Now to use that logistic regression model, I'll be using from the scikit-learn library. I'll be using the linear model and I'll just import logistic regression. This is the model name what I'm using. And again, I'm using the confusion matrix to check the metrics here. Now the name I have given LR. LR basically logistic regression model. And here I have given the logistic regression model. Random state I have given. And I have given the solver here, liblinear. Okay. I can use multiple different solvers here where my model can learn much better. Okay. This is not only the solver what we'll be using. Liblinear is not only one of the solver. There are multiple solvers what we can just use. Okay. Then we have something called class weight. So we are enabling the weight as well. Weight in the sense, suppose if you have understood the machine learning concepts, okay. So we need to balance the data. There will be something called target column, right? In the target column, there will be a lot of zeros only, and ones will be really low. So in that case, your model will not learn that much better. In order to make those data balance, so what I'm doing, I'm picking that zeros to be given as a ratio 1 and the value called 1 in terms of 1.6 or uh, giving the weightage of 1.6, increasing up to this many ratio. Okay. So basically I'm balancing the data. Balancing in the sense like if zeros are repeated 100 times, I'm making sure that one to be repeated 160 times. Okay. That is what your balancing is. Okay. You can see this is how I have given. If in the original data, if zero is repeated 100 times, okay, one to be repeated 160 times. That is what I'm balancing. Okay. I'll run the logistic regression. I'll train my logistic regression model. See, again here, the values whatever I've given, it's not at all correct. Okay, I'm not telling that you have to use the same values. Okay, instead you can use the value as 2 as well. You can give the weightage of 2. Again, yes, it's gonna work. It depends on you how much amount of values you want to put it to that. Okay, then after your model gets trained, what you'll be doing, you'll be testing the score of your model. You'll be testing the score here. You'll be giving the inputs and you'll be giving the targets and you'll be checking what is the accuracy you're getting. You'll just use lr.score. And here you can see that you are getting the accuracy of 87.2%. Okay. Now, one more thing, what you have to remember, previously, if you have observed, okay, so we had created a training data and the validation data, right? So you have to be sure that whenever you create machine learning model, it doesn't matter what is your training accuracy. You should always focus on the validation accuracy, the data which is not seen, unseen data. So validation data or the test data will be working on the unseen data, right? So you have to improve the accuracy here. So for the training data, you're getting the accuracy of 87%. Let's see for the validation. Yes, for validation, you can see the accuracy you're getting 87.7. Okay. Now, what if I just change the value here? 1. Okay, let's see what will be the change we'll be getting. You can see training accuracy got little higher, 87.6 now. Let us see for the validation accuracy. Yes, again, it got increased. It is giving 88% now. Okay, so that is how your validation accuracy will evaluate the model. Okay, then you can also take out the predictions here. If you want to take out the prediction, you can just check train threads here. This is the predictions based on the inputs data. Inputs basically the inputs, random data, and your model has predicted these outputs. Okay. This is nothing but the output which is being given from the logistic regression. Now, there is another matrix called as confusion matrix. I'll explain what is this confusion matrix and we'll go with another algorithm here simply. Okay. So in confusion matrix, there are 4 different boxes, what you can see. Okay. Mainly we have to concentrate on this TP and TN. Now let me tell you what is this TP and TN. So TP basically means true positive. TN means true negative. Okay. And this FP means false positive. FN means false negative. Okay. Now, whenever you pass the prediction into the confusion matrix, your model will tell how many correct predictions your model has predicted, how many wrong prediction your model has predicted. It is easy. Okay. Now you have to concentrate on these two values. You have to give the high amount of values for these two things, TP and TN. Okay. And if you are having high amount of values for FP and FN, your model is worst. Remember this thing. Okay. How you can check your model evaluation in confusion matrix? This TP and TN should have the high value compared to this FP and FN. Okay. So true positive basically means, let's believe that we have two different outcomes, 0 and 1. So let us assume that 0 basically is positive, 1 basically it is negative. Okay. P means it is 0, N means it is 1. Okay. So if the value is 0 and if your model has predicted as 0, that will become TP. Okay. That the count will be given to TP. And if the value is 1 and your model has also predicted as 1, it will come to TN. So actual data is also correct and predicted data is also correct. So that is nothing but your TP and TN is. Okay. FP and FN is nothing but actual data is different and predicted data is different. That is nothing but your FP and FN. So in simple terms, what I can just tell you is you have to concentrate on this TP and TN. One thing. Okay. You have to concentrate on true positive and true negative. I'll show the experiment here. See, I have created a confusion matrix here. Now you can see that your model, based on the data what I have trained, it has predicted correct answers for specific zeros. It is giving 87%, and false negative 12% it has predicted wrong. Okay. And true negative it is 0. It is giving us 0, which means your model is not good. Right. So logistic regression, my model is not good. I need to change up the values, or I need to change up the solver here so that I can improve my model. Okay. So you have to make sure that this value and this value should be higher. Okay. Instead of, you have to remove these values. Okay. Yes. And what is the accuracy you are getting? 87. See, you cannot completely dependent on accuracy score. Never ever rely on to the accuracy score. You have to rely on confusion matrix. Okay. You have to remember this thing in one mind. Okay. Was a logistic regression. Now let's go to the second model, that is KNN classifier. Let's see how our KNN classifier will work. Okay. Now KNN classifier basically, you can use sklearn library again. You'll be using the neighbors function here, and you'll be using the uh, KNeighbors classifier. This is the algorithm name. Okay. So I have applied a few metrics here. You can just understand this. Weight I have given as uniform, how many neighbors I have given. Okay. The metrics I have given. Okay. Leaf size. Okay. So based on this, let me just try to fit my KNN algorithm here. Let's see what is my prediction. Okay. So based on the training data, I'm getting 87.9% accuracy. For validation accuracy, I'm getting 87.7. Okay. Yeah, this is my predictions. So again, see here in KNN, again, I have not checked my confusion matrix. Again, if I need to check my confusion matrix means what I have to do, I'll just copy this confusion matrix function here. Wait. Sorry. My mistake. Okay. I'm creating a new code cell here. I'll just paste this here, confusion matrix. Now the variables I have to check. It is a val targets, correct? Here also, val targets, val preds, normalize equal to preds. Okay. I think I have given as spreads, right? Yes. Val underscore spreads. I need to check each and everything here. Okay, so this is your predictions, what your data is giving. Okay, so these are the prediction, and based on that, again, your model is not working that fine. See, that is how your KNN also will be classified. So this time there's a decrease in the ones here. Previously we had a lot of ones here. Again, it is not giving that much better. Okay, let's go with another algorithm again, decision tree classifier. Let's see how this will give us the outcome. Okay, so for the training accuracy, you can see that your model is giving 100% for training data. Decision tree is giving 100% accuracy. Let's see for the validation accuracy. For validation, you can see it is giving 79%. Take a look here. So this time for validation accuracy, your model is giving only 79%. Why? Because see, your decision tree will work much better than the logistic regression model. Okay, you have to understand each and every algorithm again. Okay, until and unless you decide the algorithm better, it would be really hard. And again, let us check this values here, and you can see that your model has predicted 88% zeros and 11 sorry 11.9% ones here. Okay, see, this is what your predictions is from the decision tree model. Okay, so again we have a tree here. So how you can create a tree, just to understand that one. So I'll just skip the function as of now. Why? Because other steps are also available here. I can improve my model here by running out the data, or else I can just show it. It will take just a couple of seconds here. Okay, so your tree has taken 41 depths, which means we also call it as the nodes. Okay, here I'm just giving the max depth as 3. Let's see. For max depth 3, you can see here, previously I had not given the max depth here. It was giving 100% accuracy for the training data. Now once I give the max depth value as 3 here, for the training data, there is a marginal decrease here. It is giving 87%. Let us see validation accuracy. Yes, validation accuracy, your model is giving 88%. So that is how you can just check up the values and you can evaluate. Okay, and you can also test other algorithms as well. Okay, so we'll go with one more algorithm, that is random forest, which is considered as one of the best algorithm here. Okay, so let's see what your random forest classifier is going to do. I'm going to train the data here. Your random forest classifier is giving the accuracy of 99% for the training data. You can see this is the train data and train targets. Let us see for the validation. For validation, it is giving 87.9. Okay, which means it is quite closer to the decision tree. Again, if you just provide few parameters here, or if you just apply hyperparameter tuning, your model's performance would be increased. Okay, so that is how you can just evaluate the classification model, and this is how your model will give the probability. In overcome, to give the value as 0, it is telling that 0.96% of the probability is for the 0, and to give the value as 1, it is only 0.04%. Okay, this is how you can also take out the probability value as well. Okay, so I know that a few things might be confusing as well. Okay, so because these terms are quite new for you guys, and what you can just do is, if you just refer from the start again, if you just execute the codes manually, you can just do it much better. Yes, exactly. You require the Python programming. Yes, because we are using the machine learning models manually, right? Algorithms. So yes, you require the Python programming. So if you spend like, I've already told you that if you spend like around 8 to 10 days in learning Python, yes, easily you can just create machine learning model if you start the concepts. Yes, by end of the session, again, I'm gonna share you the GitHub link so that you can just practice it out. Okay. But I want your response. Like, have you understood how exactly the flow will be in machine learning and how exactly your project is? This is another case study project. Yes, right? Yes, I'm getting a lot of yes. I want a few more response. I want you to volunteer and share your response as well. Very well. Okay. So this was another problem statement which is related to the classification. Okay. So yesterday we had covered what regression problem, and in today's session we had a discussion about logistic regression again. Okay. Right. So in upcoming days, in tomorrow's session you will be learning about unsupervised again we'll be having deep learning projects. But in order to submit your projects, you can start preparing for your projects from day one. From today only you can just start. If you have not started it, I would recommend you can learn few concepts related to the Python. Then you can just go ahead with creating the projects. Okay. And it's not recommended that only you have to do in machine learning. You can also work in NLP projects. You can work on deep learning project, etc. Okay. And I'm going to tell you few challenges in supervised learning. We have covered supervised learning problem statements, right? So here expertise is needed. Once you build your machine learning model, you have to consult an expert how your model is working. Okay. Second thing, it is time consuming in the training, like you have seen that. Third one is human errors in the data. This is also one of the major thing. Like whenever you collect the data, it is not accurate that the entire data is clean and good to create a model. You should clean the data first, and almost 70 or 60% of the time you'll be wasting over there. Then you have to create a model. Then you can just close the things up. Okay. So that is how your supervised learning will be. I believe that you have enjoyed the session and you have liked the session and you have understood the stuff. Is it a yes? Yes. So Kartika ma'am, do you have any updates for them?
Yes, Tawfiq sir. So already we have discussed about the offer letter downloading process in the start of the session. So students, we will also be sharing this session recording with you in the Telegram group along with today's attendance link. So please do go through the recording. In the start of the session, I have clearly explained about how to download your offer letter from your own LMS. Okay. So many of you are saying that you have already downloaded your offer letter. Very good. Please do help your friends also to do the same. Okay, the only thing you need to focus on is to use your AICT registered email ID. Okay, if your student ID is already there in the shared PDF, right, then which means you're eligible and you can get your offer letter from your LMS as well. Okay. So thank you so much, Tawfiq sir. It was a very fruitful session for the students. I can read their comments. Their responses is so good. Thank you so much. And
Yeah.
thank you, students.
Yeah. Thank you so much, students, and have a great day.